Hi guys, in this video we're going to cover a few theorems about similar triangles. Now, similar triangles are any two triangles that have the same three angles. Notice for these two triangles, this angle and this angle are both the same. Why is that? I wonder. I'm sure you know. If you don't know, have a think about it for a while. Okay, so these are two examples of similar triangles. Notice these ones are also right angle triangles, which is going to make everything we do much easier. But similar triangles don't have to be right angle triangles in general. And in fact, what we're going to prove works for similar triangles in general, not necessarily right angle ones. Maybe as an exercise, you can extend what we do here with these right angle triangles to similar triangles in general. Okay, so what we're going to show is, number one, we're going to show that B divided by C is equal to E divided by F. So whenever you've got similar triangles like this with side lengths E, F, and B, C, it must be the case that when you divide this one by this one on the first triangle, it's the same as dividing this one by this one on the second triangle. So we're going to show that. Number two, we're going to show that E divided by D, I better write it the other way around just to stay consistent. B divided by A is the same as E divided by D. And number three, we're going to show that C divided by A is the same as F divided by D. So we're going to prove these three facts about similar triangles that are right angled. And we're going to do so in the following way. We're going to make an observation here. First observation we're going to make is we actually have a collection of three shapes. So we got this right angle triangle, we got this right angle triangle, and then we got a little rectangle down here. So that's three shapes, which make one big shape on the outside. And the big outside shape that it makes is actually a giant right angle triangle. Like that. So we can calculate the area of this giant right angle triangle in two different ways. The first way, we can calculate the area of all the individual shapes and add them up. Let's do that first. So the area of this triangle here is going to be half times base times height. In other words, half times B times C. Well, half times height times base times height. Half CB. Plus, now let's do the area of the rectangle. Area of the rectangle is going to be, well, rectangle is two right angle triangles stuck together, so we don't even need to worry about the half this time. It's just base times height, so FB or BF. Plus the area of the other right angle triangle, well, that's just going to be half times base times height again, so half times F times E. And that is going to be equal to the area, well, the area of the huge right angle triangle, and the area of the huge right angle triangle can be calculated by taking half times the base times the height. Well, in this case, the base is equal to C plus F, and the height is equal to B plus E. Alright, so we're going to make the observation that these two things must be equal, and we're going to use this equation and expand things out and cancel some things off and hopefully get the results we're looking for. Okay, so let's go to a different board. I've rewritten the equation. I know this was on the other side before, but I'm sure you'll cope with swapping sides. Okay, so now let's expand the left-hand side. When we expand the left-hand side, we get 1/2 times CB plus 1/2 times EF plus 1/2 times CE plus 1/2 times FB. Okay, so that's the left-hand side expanded, and this is equal to the right-hand side still, haven't changed this one, so that's equal to 1/2 CB plus FB plus 1/2 EF. Wow, look at this thing. This thing looks beautiful now. We can do a whole bunch of cancellations. Firstly, we can just subtract 1/2 CB from both sides. We can subtract 1/2 EF from both sides. And we can subtract 1/2 FB from both sides. So this becomes 1/2 FB, because 1 FB minus 1/2 FB is 1/2 FB. So we just end up with after doing those three cancellations, we just end up with 1/2 CE is equal to 1/2 FB. Now, timesing through by 2 gets rid of these, and so we end up with CE equals FB. So that's by timesing both sides by 2. If they're equal to each other, they should still be equal after I've times each one by 2. So I get CE equals FB, and now finally this immediately shows us that, well, first we can divide both sides by F. So divide both sides by F, then the F's cancel, and then we can divide both sides by E. So the E's cancel there, and what we're left with is actually C divided by F is equal to B divided by E. So that's what we were, I think that's number 1, the first thing we were planning on showing. Well, B divided by C equals E divided by F. Is that what we have? We've got B divided by E equals C divided by F. Whoops. Better go back a bit. Oh, these halves can stay. Go on. So instead we should divide through by C and F, not E. So divide through by C, the E's cancel, the C's cancel rather. And if we divide through by F, the F's cancel on this side. And now we get what we were trying to prove. Sorry about that. So E divided by F is equal to B divided by C. Is that what we wanted? Yes, E divided by F is equal to B divided by C. Great. Okay, well, what the heck do we do for number 2 though? I mean, it looks like we should have, looks like we should be able to do something like that, but yeah, it's confusing. So I think we need a bit more information to take care of the second 2. And that extra information we're going to use is Pythagoras' theorem. Pythagoras' theorem. We know the relationship between all 3 of these variables. And in fact, in particular, we know that F, let me use a different color. We know that F is equal to the square root of d squared minus e squared. And also we have that C, running out of room, C is equal to the square root of a squared minus b squared. Okay, so that's probably going to come in handy. Well, let's go ahead and insert these into our formulas. So if we go back here, we had E divided by F is equal to B divided by C. And we also had that F is equal to square root of d squared minus e squared. And C is equal to square root of a squared minus b squared. Sorry if this D and A look a bit like each other. Hopefully that fixes it. Okay, so now let's just go ahead and put these ones where they should go. And that gives us that E divided by F, so E divided by square root of d squared minus e squared is actually equal to B divided by square root of a squared minus b squared. Now things are looking promising. By the way, remember, we know that all of these numbers are positive. We know that all of these are positive numbers. Keep that in mind. Okay. Now, let's multiply through. Let's cross multiply. We multiply both sides by that. Multiply both sides by that. And so we get square root of a squared minus b squared times e is equal to square root of d squared minus e squared times b. Now let's square both sides. So squaring both sides. Remember, just a reminder, I'll do it up here. Just a reminder, this a times b squared is equal to a squared b squared. Different a and b. Don't worry about these two. Not the same a and b. But in general, a times b, and you square the whole thing, it's equal to a squared times b squared. Reason being, AB squared is equal to AB, and so it's equal to AABB, which is of course equal to A squared B squared. Okay, so that means if we square both sides, it means that this thing squared times that squared is equal to this thing squared times that squared. Well, the square root of something squared, if you know it's positive, is going to be the square root of something squared is going to be the thing itself. So it's going to be a squared minus b squared. So the square root of a squared minus b squared squared must be equal to a squared minus b squared, because square root of x squared is equal to square root of x times square root of x. By definition, square root of x is the thing that when you multiply it by itself, you get x. So the square root of x squared is equal to x. And hence the square root of a squared minus b squared must in fact just be a squared minus b squared. So a squared minus b squared times e squared is equal to, and for the same reason, d squared minus e squared times b squared. Okay, things are looking promising, although I've run out of space, so let's use a new board. So we got b squared times d squared minus e squared is equal to e squared times a squared minus b squared. That's where we're at so far. Expand this out, you get b squared d squared minus b squared e squared is equal to e squared a squared minus b squared e squared. Oh, look at that. Isn't that beautiful? So now we can simply add b squared e squared to both sides. And so we get b squared d squared is equal to e squared a squared. And so that gives us, use a different color here. That gives us b squared d squared equals e squared a squared. So now we're trying to show that b divided by a equals e divided by d. Well, first I guess we can take the square root of both sides because we know it's positive. And so we get, well, we know that b and d and e and a are positive. So when we take the square root of both sides, we're going to get bd equals ea. That's no problem. And so finally, the final step, we want to show that b divided by a equals e divided by d. Well, we've already done that because now we just divide both sides by a. The a's cancel, and then we divide both sides by d. And the d's on the first side cancel. And so that gives us that b divided by a is equal to e divided by d. And that is exactly what we wanted. And I've run out of time, so I'm going to leave the last one as an exercise because I got to go do some stuff now. So it is left as an exercise to show the other one, which I think was so exercise. For an exercise, show that c divided by a equals f divided by d. It's not particularly hard, I don't think. Well, I mean, it's easy for me when I've been doing math for years to say that something's not hard. What I mean is if you paid attention to this and you think about it carefully, it shouldn't give you too much trouble. Just kind of flip the triangle up the other way if you want to and use Pythagoras' theorem again. Okay, thanks very much for watching. Hope this was useful. All the best, guys. See you next time. Take care. Bye.